Hello, good morning, good afternoon, and good evening, everyone. My name is Shrivats Upadhyay. I'm one of the public cloud advocates at VMware. Today, I'm going to talk about the right way to DevOps with Terraform and Ansible. Many of us probably agree that automation has improved the quality and time to deployment of applications to public cloud as well as to your on-prem private cloud. All of you or some of you are probably using and experimenting with these orchestration and configuration management tools already. And you might have noticed that the lines between these tools are diminishing. And that's causing quite a bit of confusion in the DevOps community as to what tool is the right tool. Should I use CloudFormation or Terraform? Should I use Ansible or Puppet? Or maybe a combination of all of these tools? Well, I'm here today to help you navigate with this. Out of all the tools which are there in the DevOps community, Terraform and Ansible stand out the most. Let's quickly look at why that is so. Terraform is an infrastructure as a code orchestration tool, right? It works with all the major cloud providers, Amazon, Google, and Azure. And unlike CloudFormation or Azure Resource Manager, it's not tied down to any specific cloud. And it has a simple client-only architecture, meaning you don't have to install any agents or maintain any other server like Puppet does. And it provides you with a simple high-level config language with which you can declare your end state. That is the desired state in which you want the infrastructure to be in. And Terraform will then figure out most optimal this workflow completed. And finally, it is immutable in nature. That means if you make a change to Terraform, if you modify any particular resource, Terraform is going to recreate that resource or is going to delete if you wanted that resource to be gone. And at the bottom, I have a simple sample Terraform code, which basically deploys 5 EC2 instances. And I've called the AMI as AMI HashiTalks. So it'll basically pick up this image and spin up 5 instances in AWS in this specific subnet ID. Obviously, along with this, you need to provide the secret key and access key to go along with and which region you want to deploy in. But at a high level, this is how a simple Terraform code looks like. Now let's look at Ansible. Ansible also works with all the major cloud providers. And even it has a simple client-only architecture, unlike Chef, which requires maintaining an agent or a server. And it has a procedural code paradigm, meaning it allows the user to specify the sequence in which the action should be taken by Ansible to reach the desired state. So it gives the user more control to decide what they want to do with their infrastructure. And finally, it is idempotent in nature. That means no matter how many times I execute the Ansible template, the end result would always be the same. And here is a simple Ansible code, right? Again, I'm trying to deploy EC2 instances to AWS with, again, the image being AMI HashiTalks on this particular subnet ID. Looks quite simple, right? So in short, both Terraform and Ansible seem to have multi-cloud capabilities. They have a simple, lightweight architecture. They have easy to write templates. In case of Terraform, it uses high-level config language. And in case of Ansible, it uses playbooks which are written in YAML and looks more like simple English, as we saw earlier. And they can execute commands on remote instances. So Terraform has capabilities where you have things like local execute and remote execute, with which you can install packages and run commands on your instances once they are up and running. And the same goes with Ansible. And obviously, both of these tools work seamlessly with any of the CI/CD tools and pipelines that you may already have. So now that we know this, which one should you choose? Actually, the right answer is to use both Terraform and Ansible. Use Terraform for its provisioning of cloud infrastructure capabilities and use Ansible for its configuration management capabilities. And let's look at quickly why that is the reason. Why do we prefer these two in this fashion? First of all, let's look at the same code which we saw earlier. On the left side, I have Terraform code, and on the right side, I have the Ansible code. On the first run, both of these templates will go and deploy 5 EC2 instances in AWS. But let's say I want to modify this instance count from 5 to 10 because I'm noticing some more load on my servers. And when I run the Terraform code, Terraform, since it's stateful in nature, it compares your existing infrastructure, right? What is deployed in your infrastructure and the state you want it to get into. So we had already deployed 5 instances and now we are changing the count to 10. So Terraform is going to deploy 5 additional instances into the AWS in that particular subnet. Sounds pretty simple. Now let's go to Ansible. What happens when I run this particular Ansible template? Ansible is going to deploy 10 additional instances to AWS, which means that you have now a total of 15 instances running in AWS and not 10. And imagine destroying these instances. Do you put the total count as 10 or do you put as 15 or 5? So that gets very tricky on the Ansible side. And that is because Ansible is idempotent in nature, right? Like I mentioned earlier, if you run the template, Ansible just gets the work done, right? It's stateless in nature. While some might argue that you can do the same thing with Ansible, right? And that's true. You have things like exact count and count tag. So what basically these two do is that they count the number of times this tag name equal to app is repeated in that AWS region, right? So if I have instances, I need to tag those instances as name equal to app, and Terraform and Ansible is going to count if it is repeated 10 times. If it is, then it's not going to provision anything. But let's say if there are only 9 instances which are tagged as name equal to app, then it's going to provision one more. And if you have more, then it's going to reduce. And as I'm talking, you might have realized that it doesn't sound quite intuitive, right? Look at the Terraform side, it's simple count, right? Well, it does not have to be, with anything like an additional tag parameter or anything of that sort. But on the Ansible side, it gets a little bit messy. So that's why +1 to Terraform for deploying on, for provisioning of cloud infrastructure. And obviously this avoids any sort of configuration drift with your infrastructure, right? Because Terraform is maintaining the state, it knows what is going on in your environment, and then it can take a diff and provision what is needed. And as we all know that Amazon, Google, and Azure are releasing a lot of services at a very rapid pace. And the dependencies between these tools is also increasing at a rapid pace. And trying to, keep up with all these services can get quite tedious. Let's say you're trying to deploy something, inside AWS with Terraform, with its declarative code paradigm. You can easily mention what resources you want to provision and in any order that you would like to. So there is no specific order that you have to follow. Let's take a quick look at an example of what I mean by that. So here I have a Terraform template, which is named fitcycle.tf. It is one of our applications which we'll deploy at the end of this presentation. But basically, I'm trying to provision a AWS VPC, a subnet, a few more subnets for my RDS, and so on and so forth. And I have described my resources over here. With Terraform's declarative code capability, I can just, delete this and let me paste it over here. So I'm writing the subnet resource first and then the VPC resource. But Terraform has, when I run this particular template, Terraform will build a graph internally. And Terraform has the knowledge, it has the data models of these cloud built in. So no matter in what sequence you describe these resources, Terraform will figure out that, hey, the first thing that I need to do is create a AWS VPC and then go create subnet, right? So it makes your life a lot more easier. You as an end user don't have to remember as to, hey, which services have to come up in what order. Let Terraform figure that out. Whereas if you were to do the same thing with Ansible, like I mentioned earlier, Ansible is procedural in nature. Means the onus is on the user to define in what sequence the services will come up. So you have to specify that VPC has to be the first service which comes up, and then the subnet, security groups, and so on and so forth, right? And let's say if you change the order of any one of these, the end result might be different, or your application might not deploy at all. That's why +1 to Terraform, again, for infrastructure provisioning. Now, let's say your infrastructure is up and running, right? What do you want to do next? Ideally, the next thing that you would want to do is configure your application inside of those instances, right? So you want to install packages, you want to install your libraries, and in some cases, you might have your own proprietary libraries which you have developed in-house, and you want to pull them from Git repositories and install them in a particular sequence. And these sequencing of actions can be done very nicely with Ansible because of its procedural code capabilities, right? So you can clearly specify that what you would like to do and what actions would you like to take inside that instance. And like I mentioned earlier, Ansible also works great with all the cloud providers. So what you can do is you can tag your instances using Terraform, and you can point Ansible to those specific instances. Let's say in our case, I want to point to a database load balancer and load a specific configuration onto that, right? Let's take a quick look at what I mean by that. So I have my structure here, right? It's like Ansible. Let's look at this YAML file. And this YAML file, you can see that I'm asking Ansible to look for all the hosts which are tagged as DBLB, my database load balancer, right? And then go to this specific role. Role is basically a concept in Ansible where we group things together. So I can go to a role and I can say DBLB. I can go to one of the templates, and you can look here at the bottom. I'm just running a for loop using Jinja templates. And I'm asking Ansible to go and fetch all the instances which are tagged as databases and get their private IP addresses and create this particular command. And then finally create this config and push it to the database load balancer. And this is quite powerful, right? When it comes to configuration of your applications, and you might have very complex scenarios which you would like to handle. So that's why, +1 for Ansible for configuration of applications. Also, Ansible provides you with some powerful conditional statements, like when. When is basically like our if-else kind of model. So you can say, if you find that this particular package has been installed, then do this, or this particular service has been started, then take an action Y, right? And you can also do situations like, if the operating system is Ubuntu, then you need to install the package in this particular sequence. But if it is CentOS, you maybe want to do something different. You can do sort of this, kind of actions with Terraform, but it's not that quite powerful on the config management side. Next, day 2 operations, right? Now your application is up and running, but you found that there were some vulnerabilities which you want to patch, and you want to release these patches to particular instances. So Ansible is again powerful in this because it's sort of, based on point number 3, right? You can easily upgrade packages in real time without, affecting the infrastructure piece itself. So that gets the work done quite quickly. And finally, Ansible also helps in dev test environments. Let's say you have a very large environment which you have provisioned using Terraform, right? Probably 30, 40 VMs, and you're using a lot of services. And these services take time to bring up. It's not on part of Terraform, but it's on the cloud side, right? Things take time to bring up. And you brought this infrastructure up, and you want to do a quick test of, if I make a change to this particular resource, or if I, let's say, upload a few static files on my, all the web VMs, what exactly happens? What you don't want to do is you don't want to bring down your entire infrastructure and then again bring back up, just to see whether minute changes have happened or not. That's a lot of waste of developer productivity, right? So you can again leverage Ansible in this scenario to quickly, go run an Ansible template, download the new files, and see if it's working or not. And then maybe you can leverage your full CI/CD pipeline to bring down the infrastructure and bring it back up. So we can see how Ansible and Terraform can be leveraged together. So you can leverage the best of both the worlds. So this is the FitCycle app which I was talking about earlier, right? You can go and look at the code for Terraform and Ansible at our GitHub repository, VMware Cloud Advocacy, and then go to VCS FitCycle deployer. So here in this, I'm deploying two Nginx web servers which have public-facing IP addresses, and all of my other instances have private IP addresses. Obviously, you don't want to expose your databases to the public IPs directly. And we want to configure these instances in a sequence, right? We want to configure the database, then the load balancer, then the application layer, and finally Nginx. Now let's see quickly in a demo as to how we can achieve this using Ansible and Terraform. I'm not going to show the automation, the CI/CD piece of it, but I'll show step by step how this would work. So you can see here we again have these 4 files: FitCycle TF, which is our main Terraform file; a provider TF, which describes how and which region I should be deploying in; and then I have a variables file, which is TF_vars, which has variable and their values; and finally a variables file which looks something like this, right? So I've declared some variables which would be prompted on the CLI, very useful for developers for testing out. Or you can provide it as part of TF_vars file. That's what most of the CI/CD pipeline tools would do. So sorry. So let's see. So first of all, I'm going to create a plan, right? Basically, plan is the phase where Terraform goes and looks if all the resources are there or not. Okay, let's provide it with the var file which we have created so that we don't have to enter all of the variables. So I'm going to call my key as HashiTalks. Do I want to use RDS database? No. Since we are short on time, I'm not going to show the demo of RDS database, but you can pull it from a repository and try it for yourself. So you can see that Terraform has identified resources which it wants to provision, right? It says it wants to create security groups, it wants to create internet gateways, SSH keys, and so on and instances. And it plans to add a total of 22 resources. That's for just a small infrastructure, right? And imagine doing this for a large infrastructure using Ansible. It would be quite tough for you to sequence all of these operations. So now let's go and apply. Apply basically means that you want Terraform to go and create this infrastructure for you. And you'll see that even though the sequence was different, it first created a VPC, right? That's what I meant by the data model capabilities which Terraform already has. So it has the knowledge. Let's look at our AWS infrastructure and see if it is provisioning. Yep, it is, right? And these were the tags which I was talking about earlier, where we saw an Ansible template that, there was a DBLB key. So this is the key, this is the tag which Ansible is looking for. So it will go and configure this particular instance with the configuration which we provided for database load balancer role. And it can do the same for app or your web servers, right? And you can see that there is, public IPs for our web servers, and none of the other instances have public IPs. And then we have a management box with which we will configure instance. And we can see that it's provisioning our other resources. And meanwhile, what I can do is I can go to my management box, right? Let's go here. And this management box has, pre-configured baked files for Ansible and Terraform. And you can see that the provisioning has finished on this side, right? And it outputs a few results, which could be quite useful, for developers. So you don't have to go to the AWS console at all. So I'm going to add AWS secret key and access key over here. Please do not embed them into your images. Always, try to pass them as environment variables, or mount a volume and pass, or use something like Vault to do that. But yeah, do not store that. Might sound like common sense, but a lot of people do that mistake. So I have this saved here. I'm going to export this so that Ansible has access. Let me go to the inventory file quickly. Inventory file is where basically you would tell Ansible as to how to go and filter out the resources, right? And the more the filters you add, the better it is, because Ansible has to run a fewer queries. And please try to leverage the AWS EC2 plugin, which is the new way of getting dynamic inventory on the Ansible side, and not the old way of doing with EC2 PY. And I'm going to quickly grab this command and paste it here. All I'm doing is I'm asking it to run this config playbook, and I'm passing the database username and password so that Ansible can go and configure. So this is the IP address on the left side. You can see where it's supposed to come up. We are supposed to see your app. So I can go to this IP. So currently, you'll see nothing is running, right? But you'll see here that Ansible is trying to install and configure a few things. And it's providing with what it has changed. So you can see that it has made these changes on these instances, right? And it has leveraged their private IP addresses. We go back here, voila, the app is up and running. So now I can sign up for a beta. I can say HashiTalks, and then HashiTalks is awesome.com, right? I can sign up and it works. And I can run this Ansible template again, but the result would be same, because Ansible will ensure that, since it's idempotent in nature, it will ensure that the same state is, the applications and the instances are in the same state. And you can see like how quite powerful, the combination of these two tools can be. And yeah, that's about it. You can follow me on GitHub or Twitter at my handle iShrivats, or you can also go to our GitHub repository, VMware Cloud Advocacy. And if you like to look at this demo and follow step by step and learn for yourself, you can visit our website at beyondvirtual.io. Thank you.